So I am doing a review of trig functions once again because the review we did in class was very quick for those of you that struggled through pre-cal. This could be extremely helpful. We don't do as much as you did in honors pre-cal. You won't be solving really complicated trig functions, but we definitely need to be able to evaluate trig functions and also look at solving simple trig functions. So to start off, we are going to look at the unit circle, which we did in class. Everything we do will be in radians. So to start off, this is 0 radians or 2 pi radians because we can get all the way around the circle. Now, up top, actually let's go all the way to the left. That is considered pi radians. Therefore, halfway would be pi over 2. Now, from here is 0. That's 1 pi over 2 up here. This is actually 2 pi over 2, which simplifies to pi. Then down here, counting, would be 3 pi over 2. Now, since we're in a unit circle, all of your points would be referenced to the center 0, 0. So this is 1, comma 0. Up top would be 0, comma 1. To the left would be negative 1, comma 0. And then down lower would be 0, negative 1. Next, we're going to look at the first quadrant. And the point that is closest to the x-axis, that is pi over 6. And we talked about in class, the easiest way to count radians is using the denominator. So this is pi over 6. This is 1/6 of a full pi. Now the full pi happens right here at this point. How many 6's go into a full pi? Then over here, this would now be 6 pi over 6's. And if there's 6 pi over 6's here, you go 1 back to get 5 pi over 6, and you go 1 forward from 6 to get 7 pi over 6. And then going all the way back around, we would get to 2 pi. Well, 2 pi is the same thing as 12 pi over 6. Therefore, going backwards 1 would get you 11 pi over 6. Next, we're going to go through pi over 4's. We're going to use that same concept to help us do our pi over 4's. That one we'll do in orange. Pi over 4 would be here. Now, if this is pi over 4, 1 full pi would be 4 pi over 4's. Go backwards 1, and we're at 3 pi over 4. Go forwards 1, we're at 5 pi over 4. Go all the way around to 2 pi, and now we are at 8 pi over 4. Go backwards 1, and we will be at 7 pi over 4. And the last piece, the very top point right here, is pi over 3, which usually gets confused with pi over 6. Pi over 3, let's fix what we have here. This would be 3 pi over 3. Therefore, 1 backwards would give us 2 pi over 3. 1 forward would give us 4 pi over 3. And going all the way around the circle, this would then give us 6 pi over 3. Going backwards 1 would give us 5 pi over 3. We're going to go straight through and label the first quadrant points. These are derived from 30, 60, 90 triangles and 45, 45, 90 triangles. I am not going to go through and review all of that with you. I am going to assume that you have learned the unit circle before if you're in AP Calc, and we are just going to write the actual values. This is root 3 over 2, 1/2, root 2 over 2, comma root 2 over 2. And then this up here would be 1/2, comma root 3 over 2. Now, what's nice about the unit circle, that first quadrant just keeps on repeating itself. And so any pi over 3 will have the exact same point of 1/2, comma root 3 over 2. The only difference is now we've gone to the left. So it's a negative x value. Coming down to 4 pi over 3, now we've gone left and we've gone down. And going to 5 pi over 3, we've gone to the right and we've gone down. And we can do this for each of the points. Pi over 4, I've gone left and I've gone up. 5 pi over 4, I've gone left and down. And then 7 pi over 4, I've gone right and down. Last one would be pi over 6s. So I've gone left for pi over 6 and up. I've gone left and down. And now I've gone right and down. So the unit circle is just to show you that all of the points repeat. It's the positive and negatives that make the values different. And hopefully notice that if I highlight all of my, let's do pi over 6s, you'll notice that every single one of them has the same exact point, only positives and negatives are different. And that happens for each of the denominators. Now, I'm going to go back through and relabel only your first quadrant in the way that I think is the most helpful. So what do I think is the most helpful? I would, hopefully get my pen back, label my radians. I would label my point. So these are memorized from the first slide. And I would, and this is a little odd, but I'm actually going to do y divided by x. So one more time, I am doing for my purple value, y divided by x. So I'm going to do the pi over 6 at the bottom here, the y value divided by the x value. So I multiply by its reciprocal, and I will get 1 over root 3. You actually can leave it like that. It's a value that you're probably not familiar with because we've simplified it. Simplified version, multiply top and bottom by root 3, and we get root 3 over 3. You actually can leave it as 1 over root 3 for our calculus class. Pi over 3 would be using the y value of root 3 over 2. Divided by 1/2 is multiplying by 2 over 1. And you get just root 3. And root 2 over 2 divided by root 2 over 2 is 1. I would memorize the first quadrant, and we are going to keep using this to help us through each of our problems. So what I'm going to do is take a picture of it now so we can use it for the rest of our problems. Let's see. Up to there. All right, so we are going to look at each of the definitions in terms of the unit circle. In case you do not remember this, sine is always your y value. Cosine is always your x value. Tangent was the reason why I did y divided by x. Cosecant is the reciprocal of sine. So let me write that here for you. Therefore, take sine and divide it. Secant is the reciprocal of cosine. That'd be 1 over x. And cotangent is obviously the reciprocal of tangent. So x over y. Tangent is also the same as sine over cosine. And cotangent is the same as cosine over sine. Some of you, I think, didn't remember each of the relationships. So there they all are. These here are all in reference to the unit circle. And why I say that, in the unit circle, the radius is 1. So a lot of you might think that you remember hearing y over r and x over r, and that's all because you were referencing every circle in the world. In the unit circle, all r is 1, so we don't actually have to write divided by 1. Evaluating trig expressions. So here is where we would do problems such as the sine of 11 pi over 6. Okay? The sine of 11 pi over 6. First of all, let's pretend that you have already gone through and memorized the first quadrant of the unit circle. So I'm going to shrink this down, keep it in the left for us. Hopefully you can see it better than maybe I can. All right, so we have that with us. how do we go through evaluating a trig expression? Here's your first step. You draw your quadrants. And you figure out 11 pi over 6. All you need to know is what quadrant it's in. So here's 0, here's pi. Now pi would be the same thing as 6 pi over 6. 2 pi would be 12 pi over 6. Therefore, 11 pi is in this quadrant. So that's the first thing you do. Second thing, you figure out if sign is positive or negative there. So here's the second thing we talked about. All students take calculus. Now, I will spell that out for you. All of your trig functions are positive in the first quadrant. Sine and its reciprocal, cosecant, are positive in the second. Tangent and cotangent are positive in the third. Cosine and secant are positive in the fourth. Therefore, in the second quadrant, the other 4, so these are all positive. The other 4 are what? Tangent and cotangent, secant and cosine. These are all negative in the second quadrant. That is how you use this. If it's not positive, then it is negative. If only these 2 are positive in the third, then the other 4, not labeled, are negative in the third. So we're in the fourth quadrant. That would be, I'm going to erase this piece right here. We are in the fourth quadrant. In fourth quadrant, only cosine and secant are positive, therefore sine is negative. I'm going to put a big old minus sign right here, and I'm going to say equals and put a minus sign. Second thing, or actually we're on the third thing, pi over 6. Let's try to remember the point for pi over 6. If you're having trouble, you can look to the right. It is root 3 over 2, comma 1/2. Sine is always the y value. Therefore, our answer to this question is negative 1/2. Let's try another example. We'll do tangent. Let's do cotangent. Cotangent of negative 4 pi over 3. So your negatives, that is where you will rotate the other way. So not in you'll be in standard position, and instead of going the positive direction, we are actually going to rotate the negative direction. So here's 0. Rotating around this way, this is 3 pi over 3. And that's all I need because the next one would get me 4 pi over 3. So we are definitely in quadrant 2. Cotangent is positive or negative in quadrant 2. It is negative. Therefore, I know for a fact that my answer is negative. We're going to look at our pi over 3 point, which is 1/2, comma, root 3 over 2. And then remember to the right, we made this tangent value. Therefore, you don't have to redo tangent and cotangent values every single time. We know that cotangent is the reciprocal of tangent, and we know root 3 is a tangent value. Therefore, I know that the answer to this problem is negative 1 over root 3. So you have to really use all of the knowledge that I just went through with you in the first 2 slides to be able to complete these types of problems. Now, in class, someone did ask me the question of, well, how do you do something like the tangent of pi over 2? Well, tangent of pi over 2, we are looking at this point here. So we're not inside of a quadrant. So we don't label it positive or negative. We will label the point. The point is 0, comma 1. Tangent is equal to sine over cosine. Therefore, it's the same as y over x. Take 1 over 0, but 0 cannot be in the bottom, so the tangent of pi over 2 is undefined. Yes, it is possible to get undefined. You will get undefined for any trig function which is a fraction. So which ones are fractions? Given each of the 6 to the left, you could possibly get undefined for tangent, cosecant, secant, and cotangent. Sine and cosine have a domain of all real numbers. So no matter what you put in for theta, you will always have an output. Solving simple trig functions.